Ladies and gentlemen, today we start talking more about limits and infinity. In the previous part, I was talking about possibility of a function to reach a limiting value which is infinity. And the example was a limit in the point x minus 3 of absolute value x plus 1 divided by x plus 3, which can be defined as infinity because, as we could see, and the details were in the previous part, grow over all limits, which means that we can claim that infinity is the value which will be reached. Now we change the point of view and we will go with the independent independent variable as something which goes to infinity. In this case, we speak about progression, but it can be also a function if necessary. But in principle, it's much easier now to explain it as a progression, where n, a natural number, goes over all limits, which means to infinity, and the members of the progression are calculated as 100 plus 200,000 divided by n. And to make it easier to calculate it, we use spreadsheet table, and we are trying to learn what is the target value. We will estimate it. And this estimated value will be our candidate for the limit. It means that we use table which is on our left side of the picture, and we see that it declines rather slowly. Its 21st member is still almost 10,000. So it goes down rather strongly, but we can hardly say what will be, if any, final value, something we will approach to. For that reason, I changed the point of view, and we will not go through single n, through natural numbers. We will go for something which I call z, which is nth power of 10. And now we see that starting from 6th member, we already are having first three digit 100, which is approximately a bit more than 100. It's visible also on our graph, where this value is practically straight line. And then, compared to the previous sheet, this part of curve declines very, very slowly. So the question is, if we can claim that 100 is our candidate, as a candidate works, but can we say this is a limit? 100 is our limit. Okay, what could we do? What should we do to confirm that this is true? First, we have to show that in sequence, the progression has declining members. So every next member is smaller than the previous one. But on the other hand, none of those is lower than 100. And finally, because we would like to go closer and closer to 100, we have to define or find out that for any small number epsilon, which is greater than 0, there is a z0 for which the inequality pz is less than 100 plus epsilon holds. And this validation must be correct for all z greater, so for all following elements of the sequence. If it is correct, then the distance between 100 and the member of limit becomes smaller and smaller and smaller, and we can say that if we would be lucky to get to infinity, we would reach the value 100, which is naturally, again, our idea, our imagination, but it's a matter of fact. So why does it hold? First, the next member of a progression is always smaller than the previous one. If you look, if P is less than Q, then 1 divided by P is always greater than 1 divided by Q, which means if we add 100 to both sides, naturally we know that for the entire progression, the members are declining and declining and declining, which means that all those z's, and if it is a natural number, then 1 divided by z is a positive number, very, very small sometimes, and smaller as we go, but 1 plus 1 divided by z is always greater than 100, which is our lower bound. And when we go back to the table, I took only last 3 members. What we can observe, I go to the next slide. Let's have, for example, epsilon equal 1 to minus 25, which is extremely small numbers, with, in fact, with more than 20 zeros before the first digit after 100. And that's what we see is that we expect that 200,000 divided by z must be then less than 10 to minus 25. And from the values in the table, we can easily guess that z should be somewhere around 10 to 17. But, in fact, in such a case, we can estimate that starting with 10 to 31st member of the progression, all others will be smaller than our epsilon, which is, I repeat, 10 to minus 25. Naturally, I didn't give a good proof, perfect proof, but when you look at these numbers, we can repeat it and we can find it. We can find even the exact value which does that. But this is not important. What we have shown is that 100 is really our limit, presuming that we would go to plus infinity. And that's everything for today. Thank you for your attention.